Welcome back to part 2 of the video. In this step, we're gonna assemble everything in SolidWorks. So let's open up SolidWorks and do File, New Assembly. Let's start out with our base first. So, base. In this case, mine's a cat. Let's also insert our crank, ternary link, and the binary link. Binary link, crank, ternary link. Just put out here for now. Now we take a look at our Geogebra file to see where all the links go. But since you made the base based on the Geogebra file, it should show up when you show the sketch on the base. So you want to go to the base and show sketch. So it's this. These lines I created previously. You can also see this is where the wheel goes. So we just insert our parts based on these locations. So let's do the crank first. I'll just hide the sketch for now. So we put our wheel hubs here, and this connects to the other side of the crank. And the crank on both sides needs to be 180 degrees out of phase. And we use the wheel hubs to lock onto the brass tube, so the rotation will be translated onto the other side with the crank with the wheel hub as well. And as you saw in your homework, when the cranks are 180 degrees out of phase, it makes the legs alternate so they walk properly. So when the left leg is at the very front, the right leg is at the very back. So we are using wheel hubs from Pololu, and then the brass tube is 0.25 inches in diameter. So it's these wheel hubs here, 0.25 inches in diameter. Now the 6mm one is for the motor, because the shaft on the motor is 6mm. So for this one, because since this is where the brass tube goes, we're going to use 0.25. Now these hubs will attach to the crank here. So you would do a mate. Let's do a concentric mate. And then also a coincident mate. Just like that. Now these holes have to align to the wheel hub where the M3 screws go. Let's mate that for the crank. So I select this surface, mate, select where the holes are on the wheel hubs, so they match. And that's it. That's your wheel hub and the crank. And the wheel hubs are threaded, so the screws will just secure on nicely. Now we want to mate the crank to the circle here. There's two ways of mating. The first way, that's what we went over. You use mate using the mate selection here, and then just select concentric. There's also another method, which is a bit faster. So what you would do is hold down your Alt key on your keyboard, and then you would drag what you want to mate. So I want to mate this circle to this circle. So holding your Alt key, you drag, and you should see like a paperclip icon on your mouse. And just drag it where you want to mate, and then it'll automatically know, oh, you want a concentric mate. And that's just a really quick way of doing it instead of going through the mate tree. Now we want to make the other links to the base. So you know this binary link, according to our Geogebra sketch, this one goes here, and this triangle goes here. So this this joint here mates with this joint. Let's double check if that's right. Oh, make sure you save your assembly. So I'll name it toolbar. Change it to inches. 8.41. Okay, so we know for sure based on that dimension there, this joint mates with this joint. So this joint must mate with that joint. Again, just refer back to a Geogebra file. It might be different from mine. So again, you will use the shortcut to make this. Hold down Alt key. Do that. And then let's make this link here. And then finally, let's link this all the way back up to the base here. Let's just double check. I think I missed this one. There we go. So what just happened there was because our links have singularities, so that's a tendency to go either one way or the other. So when it was like all the way up here, it was according to a certain singularity. But if it's down here, it's also another part of a singularity. But we want it down here because that's the way we designed it. Let's just double check if it looks right. Yeah, looks right. So now you want to start mating it so it actually represents a walker, because now we're just testing it just to see if the walking pattern and everything we designed is correct. I would say this part is one of the difficult parts to figure out the spacings between the links, because you can have it here, you can have it here, or here, here. But for this one, we're just going to keep it simple. We're just going to put the ternary link on the outside, the crank, and the binary link on the same plane. So the way you join these links together is using a brass tube in the middle, bushings on the inside, and then shaft collars on the outside to secure it. And then a spacer in between. So you leave space for screws here so it doesn't hit against the link. And also the spacers also create space for the shaft collars. You'll see what I mean after we put everything together. So let's put our spacers in there first. We know we need to have one here for sure in between these two links, because if these links are touching, then that leaves no room for these screws. So we need to have space here. Oh, that looks off. Let's just copy appearance and paste it. So let's put our spacer in between the crank and the ternary link. Again, using the shortcut, you press Alt and you drag to the circle. You can also do that for edges. So I'll drag this to this edge. That makes it coincident. Drag this to that edge. And that's it. Now you have space for the screws here. So speaking of screws, let's just put our screws in, because you want the model to be as complete as possible. So when you actually fabricate it in your future projects, it'll be much faster, much more streamlined. And you can also figure out if there's an interference of any kind. So let's put our M3 10mm long screw. So these screws go into these holes. You can also use the shortcut, the Alt shortcut. I just did it manually this time. Now another tip or trick when mating these repetitive parts. So what you can do is right click the part you want to copy with mates, click next, concentric where you want the screw to be concentric to, and then coincident where you want the bottom face of the screw to be coincident with. So in this case, for this circle, I want to be concentric to this circle, and then you want the face to be the crank. And you right click on the mouse. That's it. So same thing here, concentric, coincident, and that's it. That's a fast way of doing it instead of doing it one by one. Now let's do this joint here. So a brass tube will go in here, and then a bushing will go where the wood is. So the bushing is also in the template. It's this bushing here. Again, using the shortcut. And then you can also use the copy with mates. So concentric here, then coincident here. That's your bushing. So this bushing helps reduce the friction between brass and wood. So the brass tube will go in here, and it operates more smoothly without friction compared to without bushing. So to keep the brass tube in place, we use shaft collars to lock them on both sides. So let's grab our shaft collar, set screw shaft collar. And let's put them on both sides. Sometimes the shortcut is a bit finicky, so that's why sometimes I like to still do it manually. Again, you can use copy with mates. Concentric, coincident. And that's our joint. And now let's insert our brass tube down the middle. We will use the one in the templates folder. Brass tube, 1 feet. So the way we're going to set this up is using one part file for many different lengths on the walker. So what I mean is the brass tube for this joint will be different, and the length of the brass tube for this joint will be different, but be different for this joint, be different for the wheel joint. So to do that, we're going to use SolidWorks configurations. So what you will do is open up the part, right click on the part, open part, and then you'll go to Configuration Manager, right click, Add Config. Let's just say crank tube. Click OK. And then you will save the file. And that's made it to this joint using the shortcut for mating. Alt and drag, Alt and drag. Now make sure you click on the brass tube, you select crank tube or the one you just created. Right click the mouse button or click OK. You want to go down to your brass tube in the feature tree. And then click on the extrude. You want to edit the feature. And then you want the brass tube to be from this plane to this plane. So the length from one shaft collar to the other. So we want it from a surface, this surface, and click on this one, to this surface. And then specify configurations, make sure it's the one you just created just now, crank tube. Click OK. And that's it. Now you will do the same for all the other joints. So let's do this joint. So earlier we said we want this binary link and this crank to be on the same plane. So something like this. So you would do the exact same thing here onto this joint here. So let's do that. You can use copy with mates, but I'm just gonna do it manually because I find that sometimes a little bit easier. Depends on the context. If it's something simple, you can use copy with mates. But if it's something more complex with multiple mates, it can get confusing. So I'm just gonna do it manually. So you can copy a part from your assembly. So what you do is press control, and actually let's save our document. Okay, so you press control, hold down control, and you drag the part out. That's how you copy parts, and you can do it as many times as you like. We need that part. Let's put it here. And there you go. Actually, we forgot one step. We forgot to put the bushing in there. So let's do that again. You see it alternate between the shortcut and the mate selection. It's up to you. It's based on our workflow. And that's it. Just missing a brass tube. So let's copy this brass tube since the length is the same. So we don't need to do any new configuration or anything because the length of these two brass tubes are the same. And there you go. That's how the joints are supposed to look like when we fabricate them. So you always put a bushing where the wood is, and then shaft collars on both sides to secure the brass tube that goes down the middle. So now we want to figure out the spacing for this, the leg basically. So it looks like if we make this coincident with the base, the shaft collars will hit the base. So we might need to add a spacer here to give the shaft collar clearance. So it'll be two spacers here and one spacer here. So let's add our spacers. And then same thing here, we need a bushing. And also bushings on this side and that side. So you can see here that the distance is not exact because these spacers are 0.25 inches thick, but this wheel hub is not. So you can solve that when you're actually fabricating by adding like a washer there. So it increases this distance to make this come out a little bit. Let's add a bushing here as well, and here as well, and then also here. Flip this mate. Let's do copy with mates. Concentric, coincident, and then click OK. Now for this one here, the reason why the flange is facing this way and not this way is because when we mount the wheel, the spacer is going to go directly onto the base, and you don't want the flange to protrude out. So I'll show you what that means in a second. Let's just put it on this side first. So you see here it's flush because we'll be putting a spacer on top of it, and we don't want the flange to come out. So let's put our wheel now. So now let's put our wheel in. So it'll be in our templates, wheel, and it'll be the 6-inch wheel. And then we need the wheel adapter because the diameter of this is 1 inch and this is 0.25. So this will help us attach using the brass tube and using the Palulu wheel hubs. And then we can insert these nuts and screws later on. Let's just put it in here first. So the way we're going to mount the wheels is we're going to put spacers because the wheel's concave. So when it sits flush on the base, it doesn't reach the middle. So what I mean is like this. There's a gap here between the base and the wheel when the wheel is actually touching the base. So to fix that, we use spacers again. Let me just delete the mate. Again, hold control, and just drag it out. Just one more. I think we need 2. So let's assemble the wheel first. So first, let's put on the adapter. These holes should align to one of these holes on the wheel. And that should lock the adapter in place. So you can't ignore these cutouts because you could put a wheel hub there, but we don't need to because these wheels are freely spinning. You don't need it to lock onto the brass tube. So we can just directly put this onto the brass tube and then put a shaft collar on this side and then a shaft collar on this side just to prevent the wheel from going left and right. Again, this will be more clear once we assemble this. So let me assemble this right now. And looks like we need to add a few spacers so the ends of the wheel don't touch the base when it's attached to this circle here. So let's put these wheel hubs there. I think we need another one. Yeah, so it looks like we need 3 spacers for it to protrude out. So now let's put this here. And then you want to make this spacer to the base. And there you go. That's the wheel. So the spacers are to keep the wheel from rubbing the base. And then now you just put a shaft collar here and then one here. But let's do that later. Let's insert the screws first. The screw concentric to this circle here. And then make it coincident with the top of the screw. Just like that. And let's do copy with mates. Concentric, coincident, left click, right click, sorry. And that's it. Let's put the nut over here. See the Alt shortcut mate? Sometimes it could be a little bit buggy, so let's just do it manually. Centric. Then you want to select this face and this face. And that's your nut. Now let's just copy mate. Concentric here, coincident here, click OK, and that's it. That's your wheel with the nuts and screws on it. And let's do save. Files, save. Save all, rebuild and save. So at this point, we have finished one side of the assembly. To do the other side, we just use a SolidWorks function called mirror components under linear component pattern. Before we do that, we need to find a plane for all the components to mirror on. So the way we do that is click on Reference Geometry, Plane, and you select this face. And then let's make our walker 6 inches wide. Again, you can use your own designs. You can choose however wide you want, but for this particular walker, I'm going to do 6 inches. So this is the mid plane. So I set it as 3 inches. Once you have your plane, you want to go to linear component pattern and then mirror components. So you select your mirror plane and then you select the components you want to mirror. So let's select everything. And then you want to click next. Click the first one here, hold down shift, click the last one. Make sure you select create opposite hand version. And just double check to make sure everything looks correct. Click on next. So on this page, you want to click create new derived configuration. So that way we don't create new files for all the parts. It's all kept within the folder and organized within the folder. And then let's create a prefix. Let's just say left side. After that, click OK. And now you have a complete mirror of the right side. But if you notice, once you start moving the links, let's fix the base first. They are moving in sync, and you don't want that because you want the cranks to be 180 degrees out of phase. So to prevent the mates from synchronizing, you'll want to go to here in your feature tree, mirror component, right click and dissolve mirror component feature. Click yes. So now when you move the cranks, they are moving independently. So before you move forward, you want to double check all the parts that they're mated correctly. Sometimes the mirrored component feature doesn't mirror things correctly. So you just want to double check. So at this point, you will have two bases that are moving freely. If they're not, make sure you right click and click float. So you see this one's moving freely, this one's moving freely. So now we need to mate these two bases together so they become one rigid body. And the way we're going to do that is by using these two holes. This one here, and then also these two holes up here to align the two bases together. So let's do that. So once you have done that, you can see now the whole body moves as one rigid body. The only problem now is that these two bases are not fixed in distance. So this one can move freely. So we need to set a distance for this. And the distance we set earlier was 6 inches. So let's mate that. Click on this one, distance. Select the other face with the other base. 6 inches. So now it is completely defined. It's always a good habit to save as you go. So let's save. So now you want to insert brass tubes where it's missing. So the crank shaft here, wheel, and the top pivot. So again, we're going to use the configuration method. You can also do it manually by using the ruler and just measure a distance from here to here. And then use that distance to create another brass tube that goes through the crankshaft. But I'm just going to use the configuration method. So let me get the part, control, drag. So let's make this brass tube here. And then obviously it's not long enough, so we need to make a configuration for this length. So open, right click and open, add new config. Let's name it turning crank. Click save. And now you just want to edit the brass tube. So make sure you select the configuration you just created earlier. So in this case, mine is turning crank. And then you want to edit this part. So right click on the brass tube, edit part. And then you want to edit the extrude. So we want it from this surface to this surface. Again, make sure the arrow is pointing in. And then specify configuration. Select the configuration that you just made. And then click this button here. Let's rebuild it. And that looks good. Now sometimes when you do this, some of the brass tubes will be sticking out in the wrong direction. So for example, this might be sticking out, like that, or this one might be sticking out like that. What you gotta do is just go in and remake them. So let's say this one's sticking out in the wrong direction. So you want to select the brass tube and look down at your feature tree. And then you want to delete the mates. And then you just want to remake them. And the same thing goes for any of these that are facing the wrong direction. Because when you're doing mirror assemblies, sometimes the brass tubes, the little parts gets lost in the translation. So I'm just gonna remake these. Same for this one. Let's delete these mates. Remake them. See, sometimes it'll be like this. So what I just did was click rebuild, and then these just went in the wrong direction. So again, you just want to redo it. So let's do this one first. Let's right click and flip mate alignment. Let's try flipping the mate alignment in this one too. And then click rebuild. Okay, let's redo it. And then let's click rebuild again. And that's fixed. So if you meet these errors, just redo the mates. What I would do now is click save, save all. And now you want to do the same thing, but one brass tube here and one here. So control drag. But before we do that, we know we need a shaft collar here and here. So let's get one here. And you want the same thing for the other side. So now we know the distance we need for the brass tube. So let's make this brass tube. And then, as you can see, it's not long enough because this one was the brass tube that was here. So again, let's do the configuration method, or you can do it manually using measure and then creating a duplicate part that has the correct measurements. But let's just do the configuration method. Let's add a configuration. Let's name it top pivot. Again, same thing, edit the part, the extrude. So let's rebuild. This face to this face. Oh, we forgot to select top pivot. Okay. Now we can edit. Specify config, the one we just created just now for the top pivot. And then you want to click this button here and rebuild. Looks good. So now we want a brass tube for the wheels. And again, we need a shaft collar here and here. So again, control drag. Same thing. We're doing the same thing as these tubes here. So I'm just gonna speed through it real quick. New config, wheel, save. Make sure you select the wheel config. Then let's mate it. Oh, before we do that, let's add the shaft collars. Again, for the other side. So now let's insert the brass tube. And then again, you want to edit. To extrude. Specify configuration, make sure it's the wheel. So from this surface to this surface on the other side. And that looks good. You are about 70% done. So now would be a good time to save. And then we also need shaft collars on the insides too. So let's insert those. So just do copy with mates. Actually, no, let's mate one first. And now we can copy with mates. So concentric, coincident, right click. Same thing here. Concentric, coincident, then right click. Do that again. Down here on the wheels too. Let's flip this. There we go. So now we have shaft collars here, shaft collars here, 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 and here, and we need one more here. And that's it. And click save. So the next part will be inserting the motor, the gears, and the battery to make this more complete. But first, let's make sure the cranks are at 180 degrees out of phase. Let's do a parallel mate. And then let's flip the mate alignment. So now they're at 180 degrees when you rotate them as well. So now let's move on to the gears and the motor. Now we're going to insert the gears, and first we gotta size the gears and know how big it is on our walker. So use the gear template that's given in the Google Drive. So gear. And then for this project, we're just gonna keep it at default. In the future, in your future projects, if you need to size the gear or change the diameter or the teeth, you can do it. You can do it here. Here, you can manage the equations. So, for example, let's say I want 20, and then 3 here. Click rebuild, and then you can size your gear however you want it. So for now, we're just gonna keep it at default. And then what we want to do is measure how big the gear is. So I'll put the circle around here because we want to leave space for the other gear to mesh in properly. So let's see. It is about 37.45 millimeters in diameter. So what you could do is click on this entity and then click press Ctrl C to copy the sketch. And then you want to go back to your assembly, open the base, and then do a new sketch on this face, and then press Ctrl V. Let's give it a dimension. .45 millimeters. So that is our gear. And the reason why we do this is so we can know where to put our gears and where to draw a hole for us to extrude cut. So we know there needs to be a hole at the crank. Let's copy this again. And we want the gears to mesh properly. So we want these two lines to be tangent. First, let me add a dimension here. And you click tangent. So you hold down Control and you click the two entities, and then you click tangent. So now we know like this is where our gear is gonna be. One on the crank and one where the motor is going to be. The reason why we make these sketches is also for later. It's easier to mate the gears and to mount, and use this sketch to mate the mounts and know where the mounts should be. So let's make these sketches into a construction circle. And then let's make these 2 points horizontal. And let's draw a center line or horizontal line. Make this horizontal. Just so we can reference back to it later. Because we don't have anything here that's horizontal or completely straight. It's all rounded or at an angle. So this is helpful later when we make parts. Let's just fix this so it doesn't move around. And then you want to exit sketch and then save. Yes. So now we have a horizontal reference frame and also circular holes, so we know where to mount our gears and motor. Now let's insert our motor and motor mount. So the motor bracket, let's assemble this, mate this. Make this concentric to this, coincident with these two faces. And then mate the holes correctly. Because this top part should be rotated down here. So let's make that. And that's the motor. The Polulu motor bracket actually comes with screws, so we won't put it in here now, but when you guys get the physical model, there'll be screws for each of these holes and also screws down here. So when we get the motor mount, it'll come with 9 screws for each of these holes. So now let's insert our hubs. Since this is the motor, this is the shaft for the motor. The motor shaft is 6 millimeters. So we use the 6 millimeter hub. And let's make these two. It's in the wrong direction. No, it's the right direction. Let's make this face with that face. Let's insert our gear. So the gear will go on the wheel hub. Let's make that concentric to the wheel hub. And then make these faces coincident. And then let's line up the holes. 1 is enough. So now you have your gear, your wheel hub, the bracket, and the motor. We want the model to be complete, so let's add in our screws too. So these screws go in the motor hole, the gear hole, and screws onto the wheel hub here. So it secures the wheel hub and the gear. Let's just make that real quick. Concentric. And then make sure these two faces are coincident. So just do copy mates, copy with mates. And now that is where these holes come into play. So we can use the holes to mate this at the correct location. Since these are all concentric, let's just choose the hub surface, click mate, and then we want the motor on this circle. So make sure it's concentric. So now that is where we're going to put our motor with the gear. So next, since this is not oriented correctly, we're going to use this horizontal line to orient the motor. So click on this face and the horizontal line. Make sure it's parallel and click OK. So now the only motion is this motion. But what we could do, just click on any face. Let's click on this face, click mate. You want to click this symbol, the lock button, and select the base. What this does is it locks this the motor and the motor mount at a certain distance to the base. So now it does not move. It will move with the whole body. The next thing you want to do is insert the other gear on the crankshaft. So let's just control drag. And then we're not going to use this wheel hub. We're going to use the wheel hub that's for the brass tube, the one that's 0.25. And then we're going to do the exact same thing as here with screws and the wheel hub mounted to the gear. And then we want to mount this to the crankshaft here. So let's insert some screws. We can just use copy with mates. Let's mate this onto the crankshaft. And then let's make these two on the same plane, the two gears. we want to check if it's meshed correctly. So to hide an object in your assembly, just hover over it and click tab. So we can see it's not meshing correctly because it's way too tight. It's touching into the other gear. So we want to separate these two circles a little bit further. Oh, separate this circle further. Or increase the diameter. Edit sketch. Let's just increase it to 37. Looks like it's showing errors here because we locked the motor to the base already. So let's unlock that first. This one. Let's suppress this first. Let's increase the diameter. Oh yeah, I shouldn't be 30, so it should be bigger than this. So let's do 40. And it looks like, yep, that looks like it's better. So just make sure you unlock the motor mate to the base before you're doing this, because if it's locked in, it'll be conflicting mates. Because you're telling SolidWorks that this gear should move over to the left, but there's a mate here that's locked into the base. So just disable the lock, and then after you're done, just lock it back up again. So the motor doesn't go left and right freely. And then to show the part that you click on the screen here, show hidden components. You want to highlight everything. Click on it, and then click exit. So now this won't move because we relocked it earlier. Okay, the gears will move. We will make these correctly with gear mates later, but for now, let's just let's make the motor base here, because the motor is floating in midair right now. So to make the motor base, we're gonna use this, insert components, new part. But first, let's make our walker, let's make this line horizontal. So let's float our walker so it moves freely. Select this line, click mate, and let's mate it to the top plane parallel. It'll just make our drawings easier later. And then let's disable that for now. Suppress it. And then let's fix our walker. So let's insert new part. Click anywhere on the screen. Scroll down. You want to edit part. And then let's hide this space because we can't see the motor. So now we want to draw a box down here for the motor mount to go on. Sketch, click on this face. Let's just draw a rectangle. It'll be 0.25 inches thick because that's the thickness of our wood. And then we want the base to be 2 inches wide. Next, we want this to be up here. So control click on this edge and this edge and make it collinear. Then next you want to align this so it's in the middle. So if you just hover over this line, you'll find this midpoint. And then while holding down your control, hover over this line, and then you should see the midpoint as well. You want it to be vertical. So now it's in the middle. And next you want to extrude this. So our width of our walker was 6 inches. Let's just show. Extrude 6 inches. Click OK. And then we want the appearance of wood, so let's just copy appearance, paste onto the part. That is your motor base. And now's a good time to save. Save internally. And then we also want to lock this motor base to the main base, but also move around. So mate, lock to the base, and then click OK. So now it won't move around. We can hide these sketches. Then now we want to mount something like a L bracket so we can secure the actual motor base during fabrication. Because right now it's just SolidWorks, but we want something to actually hold it in place when we're building it. So for that, we're going to use something called a nut strip. These nut strips, they are threaded, so we don't need nuts when we use a L bracket. We just directly screw in our screw onto the nut strip. So we just want these on the bottom here. So I'm gonna make that real quick. And then make sure it's in the middle. So I think it was, let's try 2 inches in the other direction. Oh, it's 0.2 inches. And same for the other side. So that is our L bracket slash nut strip. So last thing we're going to do is just make these holes on the base, because when we're manufacturing them we use laser cutters, so we can cut these holes so it's more precise when we mount these L brackets. We don't need to drill holes or insert screws or tap them. So let's create the hole for the motor mount first. Let's make this transparent. And then we would do sketch, circle, select a plane. So let's just select the base, the motor base. And then it was, our holes should be 3 millimeters. Make sure you change your units, because our screws we're using M3 screws. And same thing for these two holes. 3 millimeters, 3 millimeters. So now you want to use, you want to create holes for these nut strips as well. So again, it's 3 millimeters. So now you have all these holes that are gonna extrude cut into the base. So what we want to do is click on assembly, assembly features, extruded cut. And then you want to do through all, and make sure your feature scope, propagate feature to parts, unclick auto select, and you just want to select this, the motor base. That's all you want to cut through. And let's make this not transparent. So now you see the holes made for M3 screws when we use the laser cutter to cut through them. Now you want to click on File, Save. So now we want to create holes for the M3 screws so they can screw onto the nut strip. So we make the holes on the base. So let's make this transparent first so we can see the holes on the M3 nut strip. Sketch, click on this plane, circle, and then it's 3 millimeters. Same thing for like what we did for the motor base. Click on assembly, assembly features, extruded cut. You want to select through all both. Uncheck auto select, and you just want to select these two bases. Change transparency. Now we have the M3 holes for the nut strip that secures the base and the motor base and the base. To be complete, let's insert our M3 screws onto the nut strip. Just mate this to the nut strip here. Let's do copy with mates. Same for the other side. Let's flip the direction. Same for this. And also the top. And the bottom. The motor bracket will come with these screws. So you can choose to use the screws that came with the motor mount or the M3 screws that we're going to purchase. So the last thing we want to insert is our battery. It's called battery pack. And then you can put this anywhere you want. I'm gonna put it right here. And then I'm just gonna lock this to the base. So it doesn't move around. And now you want to click save. So that concludes our second part of the video. The third part, we're going to focus on making a motion study. Basically, that is just an animation based on our walker here.